Hello everyone, welcome to today's presentation. I'm Michał Sikora and at TrueSoft I'm a business development manager, and today I would like to show you Impact Revit, its functionalities, how it works and how it can improve your workflows in your precast factory or design office. So without further ado, let's see what we will be talking about today. So first and foremost, we will talk about precise modeling of elements in, of course, Impact Revit. We will be adding casting materials, a lot of them automatically, according to the definitions in the elements. I'll show you some powerful rebar templates in Impact Revit, which will automate your reinforcement work for your precast elements. We'll generate shop drawings. We will also talk a little bit about creating OBJ files, how to do that in Revit. And I'll show you the 3D preview of elements in Impact Project Manager. So without further ado, let me actually go ahead and open Project Manager for you. So I've got a project started in Impact Project Manager. So for all those who are new to Impact and don't know what it is, it's a big piece of software directed towards designing and planning production of precast elements. Today we will focus on the design side of things and on the module that's an add-on to Revit. But the heart of Revit, the heart of Impact is Project Manager. So what you see on the screen right now, and you see some grid lines here, so structural axes, call it what you will. I've already have those defined in my project. Now, Impact is a database-driven software. So you actually have to create this data somehow. And how do you create that data? There's a couple of different ways, but of course the most easy one with Impact Design that you have is actually using the tools at hand, either in Impact CAD or Impact Revit, to create the elements within the software and save those elements to the database. All the intelligence allocated with those elements, so your volumes, your areas of elements, your concrete grade, the reinforcement, the casting materials that are added, the qualities and quantities of the casting materials, the reinforcement. All this data will be saved to the database and the intelligence will be there in the database. Once everything is saved to the database, it will be visible in Project Manager. We don't have any elements on the screen right now because we haven't modeled anything yet, but that's not a problem. On the left here, there's a tree. That's how you navigate in Impact Project Manager. You can navigate by floors. I already have a couple defined in this project. You can navigate the drawings that you create. We haven't created any yet. So we'll fix that in half an hour or so. Next, you've got project files, and there's the Revit file. This one is, you create a new Revit file according to the template in your standard. I already have that one open, and I've opened Revit before the presentation just so we don't waste time actually waiting on that. And you can see those are the grid lines we had on screen. What I have here is the plan view of the model. And we can of course also open the 3D view, and you can see we have some levels designed. So I've got the level 1 open, and without wasting any more time really, let's actually start modeling elements. So in Impact you have to have a predefined standard. In Revit you will be utilizing the Revit families to create element types and various definitions of those elements. We won't be creating a fresh one in this presentation, but we will be utilizing what we have defined in the standard. Creating a new one would simply, it wouldn't be, very time sensitive, or rather time conscious for the presentation. And I don't want to waste your time on that. So without any more discussions, let's go and actually start drafting some walls. And you'll see that we have 3 levels in Impact. That's the project level. So all the elements that are types of elements that are defined inside just a project. There's the local level so basically maybe maybe like a factory level, that's something just available in one particular factory, or a common level, so all the types of elements that are available in your company in general. So if you have multiple factories, you can have one factory with some local standards, some elements only there, produced there, and another factory where some elements only produced there. Some particular project when you will create something, say bespoke, and you've got your common level with standard stuff that every factory in your company does, or something that you design for a lot of precasters, and that's very common in the industry. Let's go to project level, and we also have a type for the wall. So we can have a solid wall, which is defined in impact as a wall, or an insulated wall, or a sandwich panel. We'll deal with sandwich panels today. I'll select those. But before we go, I'll just want to show you some part of the definition. And in when I click edit, a window will pop up where you will be able to slightly edit what you have within the definition. It's first time today that I'm running it, so it's a bit slow, but no worries. So in here you can define your layers on what it is, what the layers are. You can define which side of the concrete panel is up, which is down, and you can also define which reinforcement template is the preferred one for the particular elements that you will be placing. You can also define lifting points and bracing points, and casting materials that are automatically used when you place those elements. So that is out of mind when you are dealing with that. You don't have to think consciously about adding a lifter, or adding a bracing anchor, or adding a surge protection, steel casted materials as well. You can add a lot of stuff automatically in here. Basically, you define some distances, default distances between elements. You define at which mass which type of lifter is assigned, and you get a little sketch here that allows you to specify according to the center of gravity or the face of the element the exact placement, for example, of the lifter. Then you've got the bracing points and how they are placed, whether it's part of height or a fixed distance. So of course, some definitions here, and the naming scheme. So maybe you want your sandwich walls not to have a prefix SW, but something else, and of course you can edit that here. I'm just going to cancel out of that, not to unnecessarily edit anything that I don't want to edit. And with that, let's actually go ahead. Once I click OK, I will actually move to the placement option of the wall, which takes an unusually long time. Oh, because I didn't click OK. That's silly me. With that, I selected definitions. Sorry, got mixed up straight from the presentation. I didn't select the option to draw wall. I selected the option for definitions to show you the definitions of the wall. But let's select a sandwich panel, and let's select the available SW33 wall. And you've got a little preview here on the screen as well. There's a question here about a vertical gap, if we want one, but we won't be dividing the wall yet vertical. So I will create large panels with no gaps, and I will do that on purpose, just to show you how easy it is to later modify and edit. So let's go ahead and do that. You'll get your standard Revit tools and options here on top of the screen, and I actually want the walls to reach level 3, and I want to have a finish face interior available, and I don't want to automatically join the walls. That's because we have our own impact tools, and the Revit one doesn't really comply too well with that. But still, it's a drawing option here that we need to be conscious of removing. And I'll just draw the walls for us. Basically, big panel here, like that, like that, like that. You see how fast the modeling itself is. Basically, every single time I do that, Impact automatically places casted materials, properly selects the layers of the elements, get the lifters in, get the bracing anchors, etc, etc. However, I will get a warning now once I escape out of that, and that's the warning. Impact warns you that this wall is massive. It's 30 odd meters long. It's too big for any kind of lifter that we have defined in the database, and Impact warns you about that. I'm going to take a sip of water. So you've got that intelligence in the background warning you about some issues that might arise in your design that you're doing. So we've got our sandwich panels in, and the wall is too big. Those two walls are also too big. This is not the first time I'm playing around with this particular model and grid line system, so I know those others are too big as well. So I'm just going to apply that. Ignore this warning for now. That's because once I divide the walls into appropriate sizes, the lifters will automatically come. There is intelligence to automatically add them once we edit that, so the lifters are there, and we don't have to worry about it too much. And now Impact does all the geometry. Basically, Impact worked in the background, it did everything for us, and now, of course, we have our big elements. You see, those are big balls. What I'll do now is I'll divide those in smaller segments vertically. So since those are tall walls now, basically 2 stories tall, I'll divide them up and start adding end caps to them. Start dividing those walls in vertical sections, and then once I'm done and applied some connections and connected the walls, applied some joints, then I'll just divide them horizontally as well, just so we have 2 floors of walls. With that, there's a very simple function in Impact for Revit, and that's going to be a split wall vertical, and that asks me to select the walls that I want. And doesn't matter which panel I actually select in this view. I just click finish here, and with that I will need to select reference planes. So those are my Revit axes here, and I'll just select all those that I want to be used for division. I want those walls divided and those walls and this big wall divided, and just click finish. What happens now is Impact will allow us to select a end cap that will be applied at the dividing point. So that's why I didn't bother with any other settings while I was placing those walls. Now it's super easy for me to just select that, and all the ends of the wall will have where the division was made will have this end cap applied. So it will be much easier for me to then connect those walls with cast-in material. Though it will be as well automated in most part. I've applied the gap of 20 millimeters. We are splitting the walls. Sorry, that's Windows 11 for you. I just wanted to show you the bottom left corner of the screen, and now everything is divided. If I zoom in, we've got a division here and apply the end cap. If I go to the 3D view, the walls are divided, and you can see that we actually have some lifters applied in those walls now. So they were too big, they didn't have lifters. Now they're small enough that lifters can be applied. Small enough, it's probably still very massive walls, but we've got those applied. Now that we've done that, we'll start connecting the, say, corner points, and super simple as well. There's a option to connect wall, and in Impact you can define. You saw me actually selecting the end cap from a drop-down list for this particular sandwich panel, and that's because you can have multiple end caps defined for a particular wall type, or a hollow core. You can have different end caps as well, or for solid walls, etc., etc. We'll be working with that a little bit later, but still, it's going to be fine. Now, what are we going to do? I'm going to select this wall and this wall, and I'm going to click finish. Impact will try to find one of the definitions that we have, and in this case, it actually found it. It will apply one end cap like this and the other end cap like this at the connection point. It will properly extend those elements together, and it will apply the cast-in material that we see on the screen here. So basically, wire loops on the in the V cutout on the wall. But you can also have different variants. So Impact will also show you the options of the connection. In my case, I want the connection to be like this. So I want this wall to extend here, and my wire loops to be applied in this direction. So I'm just going to click OK. And in this window, I can specify how many of those cast-in material wire loops I want. I can have a placement preview. Basically, that's the setup. That's the dimensions that I apply. So my A and B dimensions are by default 600 and 400 mil, and the spacing between the wire loops is 300 mil. And I'm fine with the settings as they are. Of course, you can use different cast-in material from the drop-down list, and you'll see them change in the preview as well. So not a good one in this particular case. So let's just move back to the other one. But we have, of course, a library of cast-in materials. You can add to that. You can create your own. Nothing stops you from doing that. I'm just going to accept that. And we got our connection between our walls and cast-in material is added. Now, if I don't click finish, I can go over and select the corners of the same type that I see that can be there, and I can apply that connection as well. So I'll do just that. And you see now the orientation of the walls will be changed, or rather not the orientation, but rather the end. The wall on the top has been shortened, and the wall on the bottom has been extended to apply for that corner definition that I defined. And I can just quickly go over and do the same thing. For the external corners, basically like that, finish. And yeah, let's go option 2 here. Yep. So we don't shorten this wall to make it too short, like that. Oops. No, that's good. That's option 1. Yep. Like that, and we'll click like that. Let's make it the same. Yes. What's the other side? Like this. Oh no, I actually want this one to extend. Yeah. And this one like that. So this will actually cover all the external corners for us. Of course, that's not the only type of connection that we have defined in Impact. For example, oops, I'm just going to cancel out of that and get the connection again. Select these two types of connection, and we get, for example, a proposition like this to connect those two walls. And I'm gonna set the default settings as well. With this one, you just have to also select the origin point, so you could potentially move that connection point left, right, however long you want it along the length of those two walls. I won't be connecting those two, but I maybe quickly click those two and get them a connection like that. No worries. That's because origin point, click. You see I misclicked on the snap point and it moved the connection slightly. No worries, I think we can still go ahead, get that connection in and move the origin point to here. And it moved that nicely for us. I'm going to finish that as well. And what we forgot to do, or I forgot to do, is I forgot to actually draw some solid walls, which I'll do just now, right now, for us. And let's actually start doing those. They're gonna be connected same way. Wall, center line, finish, interior, disallow connection, and we're going to go like this to here. Yep. And I'm going to change that to finish face, exterior, like that. Okay. Same thing. Like that. And I'm going to go center line now. Like that. Of course, those are some warnings about the size of the elements, so no worries, we'll divide those again. So that's the warning. Those walls are too big. A lot of solid walls are too big. I'm just going to apply to all. They're too big, so we'll just split them vertically. I want to select those walls, and they should be fine. So I'm just going to finish, select this one, finish, and get the, not this one, 801, I think. No, it's not 801. Oh well, I don't need to apply an end cap, a specific end cap between those two. We'll do a connection anyway. This will be a 3-point connection between those walls anyway. And again, 3D view, we've got everything in. It's there. No more warnings about the end caps. So super easy. Again, let's quickly do some connections so you can see some more complex connections between the elements that can be placed, like that. That's an example. Doesn't give you more options. It's only one way those walls can be connected, like so. Oops, click that. And default options as well. They should be fine. Like that. Like that. Oh, there's no joint that's possible for this. And like that. And okay. And that's super easy. And again, some 3-way connections. So finish, connect wall, click, click, click. It also gives you an idea. This gives you more options, like so, moving the connection around. I prefer to use the main one and just accept that. You can of course edit the placement of the casting materials, etc, etc. Of course, super easy. Like that. Get those connections in. Now I don't want to go ahead and do all the connections in all the elements because it will be just too much time to spend on that. I'll just do those 2 more. Like that. And accept that. And accept that. That's fine, we'll be dividing the walls anyway. Same thing. We'll be dividing the walls anyway. And this one I unfortunately made the other way around. Didn't focus on that. Doesn't matter. Now let's divide the wall horizontally, so you'll see it's the same process as is for the vertical, except select of course the walls that you want to divide. Doesn't matter which panel you select. Make finish. And now, oh, sorry, I need to select the, let's save the project. I got a warning of that. Let me select my sandwich panels first. I'll divide those up. That's not a sandwich panel. Let's remove that. Okay. Impact. Let's split with horizontal. Why? Because I can select the end caps now for the connection. And let me go ahead. As you can see, you can automatically select the type of connection. That's this one, and I want to use this one. And you can make it lower. Sorry, you can lower the end caps properly, so they're well aligned. So whatever end caps you have defined, this will be the top of the bottom wall, this will be the bottom of the top wall, and you can specify, for example, that you want to divide up the walls by the elevation, which I already have defined here. So let me just select the plane, click finish, and you can already see the impact doing its magic, working and splitting up the walls according to the elevation that we have defined. So it will take a short little while, so the geometry is all applied, no worries there. It will get done. We'll also split the internal solid panels, and after that I'll show you how to add openings, how easy it is, how to place them. Of course, those openings you have to have predefined in Impact, so as basically anything that typically would happen when modeling in Revit. You would define your families and have them ready. With Impact, it's very similar, in Revit at least, to very much have some stuff predefined and ready to go. We already finished. We're just missing like those two walls, I think, and maybe not only those two. There's probably those as well. And I think that's the last one. And like that, in say 15 minutes since I started doing that, we have basically the walls of the building done. So no worries there. I'll select the internal walls as well. This will be much quicker as there's way less of those. Let's divide those as well. Those I will just yeah, let's make a 20 mil gap between those two layers, and let's select the elevation and finish. So super easy, very automated, adds a lot of stuff. Impact does a lot of stuff automatically for you. So your job is just properly modeling the elements, and then once everything's ready, save everything to the database and create the drawings. Simple as that. We'll do that just shortly. Just have a little bit, a couple of different elements to add. So we've got that. Let's actually go draw an opening in some sandwich panels. I'll select the openings defined for sandwich panels. Let's go with the big windows here. And we've got, of course, some definition. So if I go ahead, open the definition, F14B, double click. Here you specify some dimensions, how it's placed, what are the end caps for each edge of that opening. You can have production code. If there's some cast-in material to add, and of course you could add that to that particular cast-in material, but super easy. With that, just a matter of actually placing the elements. Let's go middle of that wall. It will do this for you, and let's go add that in the middle here as well. I'm going to close that out because it takes a little bit of time for Impact to add those openings, and I don't want to waste unnecessary time for the program to just think in the background while we yep, that's probably what we probably have here. Yeah, we probably removed the from lifters, probably we removed some concrete panel thickenings because of the openings. So of course that's some information for you that pops up with Impact. So we've got that done. You see how easy it is. We've got the openings ready. Of course, we'll create some drawings for those shortly. With that, let me first draw a column as well. Very similar to to how you do, very similar in how you place it. You select from definitions, you select your columns. I'm going to select some here, place it like that, and place that here as well. So we've got our columns. One thing of note, I mean, we'll deal with that in a second. Like that, that's good. And that's good. So that's placed. And escape, we've got those. Of course, I forgot that in Revit you actually have to place the levels from which you want to operate. Doesn't matter. Let's select all those elements. We'll fix them. Base offset is 0. Top level, cancel. Top is second level, and that's 0. And let's apply. I want to update the lifts. Apply for all elements. Update. You see, if I do some changes. Oh, that's fine. Yeah, that's good now. So we've moved those columns. One thing, I will be wanting to add corbels to this face. So what I want to do is I want to rotate the face of the column, change cast orientation. So I want to now specify an element front face like that. Impact. Sometimes for some reason it doesn't want to change the orientation for me. Okay. I'll go back to the top view. Sometimes it's much better to do it from the top view. Okay, now it rotated that to the other side, which is good. And let's actually do the same thing for this one. Okay, so we've got this rotated, that's fine. So we will be able to actually have the corbels. So you see, columns, easy. You have column definitions here. You can change some. Here you can either create a family or load column the family. You can apply some chamfers that are automatically applied once you place the column. You can specify the lift points. So we rotated those to the other side, and that's how you define those. Let's cancel that out and let's draw beams now between those two. I'm going to draw a beam section and I want an inverted T-beam. That's like that. You've got parameters as well. Placement plane, that's going to be level 2. Yep, from here to here with some offsets, and let's do the same thing for the other side, like that, and like that. Easy, convenient, escape, escape. Let's see if my Revit skills are good. Yes, I remembered about the proper placement of that. One thing, maybe start extension. Let's go -20, -20, apply. Yes, and I want to do the same thing on the other side, just so we have some. You see how easy it is to edit, but of course those are Revit tools to edit families and beams and whatnot. So of course it's super easy and convenient. But now we got the beam. We haven't applied any reinforcement yet. With that we'll do in a couple of minutes once I'm done, like with the geometry, etc. So it's super easy and convenient for us, right? So it's going to be fine. How to do that? Super easy. Let's add corbels to the columns and see how super easy that is. We go to components and actually we'll go and use the insert corbel tool, which I want to use the corbel with a socket. and I'm gonna use this corbel because this one has a nice little slanted bottom top. This is just like a rectangular corbel, not perfect. So let's use the second one, and I want to use those elements and those elements. Oh, sorry. I can only use one selection like that. Boom. We've got the corbels applied automatically. Let's repeat the tool like that, finish. What I want to fix with those corbels though is I want to extend them full width as well, and that's just a simple little tick here and apply. And now my corbels are full width. If we go to the 3D view, we've got our corbels selected nicely and visible, and this is a nice geometry. You see the chamfers as well that we defined, and now we don't have any lifters on the corbel side, so it's there. But corbels do have a socket there, so let's edit the beams as well. So you can see, let's do that. So we can edit the beams that we have selected, and for example assign an opening, single symmetrical, let's go 80 for the diameter, and I think it's go 70 or 65, I think should be good. Copy that to the other side, apply. Oh no, we need to edit that again, so we need to move that slightly further. Let's go 90, copy, apply. Almost perfect, but I think you get the idea. If we go to the 3D view, we now have an automatically placed. I think it's too close to this face of the beam, but still, that's something to, this is an ad hoc session, so of course in your projects it will definitely look slightly different, probably better. So with that, we've got all the editing and adding and creation of the wall and beams and columns, but let's draw some flooring systems as well. So let's actually do hollow cores for us. Okay, so let me now go to the option to draw hollow core sections. Yep, and one thing, I'll place them on zeros. I need to close that out. Let's go to the level 2 actually, and in level 2 we'll draw some hollow cores. In hollow cores, in definitions, you can define the shape of the hollow core, the strands, the strand layouts as well, so you can have multiple different strand patterns. That's up to you to define those for your project. What we'll do now is I'll select a boundary by drawing a rectangle, and I'll draw that rectangle here from this point to this point, like that. And you can see that I've placed the hollow cores in an incorrect direction. So let me actually select the direction, and let's just select the face of that wall. So now those are aligned. You get a preview of the cut element as well. That's here. So we'll move that slightly. You'll also see that the hollow cores extend slightly here, and they don't extend to those walls. And that's what you set in support length end cap. You get a little preview of your shape, and you specify, if you want any offset to support on some other elements on particular edges. And basically you select the edge, you specify the value here, and you go edge by edge and select that. I'm happy with what I see on the screen, so I'm just going to accept that. What I'm not happy is, say, with the placement of the cut-off hollow core. So let me move that one up. And there's also a second element of hollow core, like a super tiny sliver of a hollow core here, which I'm not happy with. So I can just not create that. Okay, so that's something that we can do. And I'm just going to create those hollow cores like that. Okay, so that's how you would do those hollow cores. Of course, you can select those. I see. I also forgot that maybe we can change the origin of the in the view. So I'll just repeat the process and just show you how that is done. There's also a pick insertion. I forgot how to forgot to show you that. So I'm just going to repeat the process. It's very quick, so you'll notice, you'll see that it's super easy. So now, again, select direction like that, and I'm going to pick an insertion. I've got a little help here with. Okay, so port and cap. That's okay. Oh, for some reason I can't pick an insertion. Okay, why? Basically pick an insertion. For some reason it doesn't work for me today, which is weird because I did test it, but for some reason it doesn't want to move for me. I wanted to pick an insertion just to move the hollow cores to start at like this edge, so then I would have one cut out and basically the whole layout would shift slightly, but for some reason it doesn't want to do that for me. Yeah, let's go and place that by the top as well. And let's remove that and move that cut out one inwards. And we'll just do it slightly differently. So no worries. And we'll have some hollow cores placed in a couple seconds. What? Something weird happened. Did I not? Okay, that is. Oh, probably the. I probably placed those, but I don't see those in view. Am I correct? Yes, that's correct. What was that? How did you change the view? That's a problem. I'm going to change the assignment of those. Select all instances visible in view. That's fine. That's fine. We can work in like a 3D view anyway. Or justification. Top. Okay, that's fine. That's fine. Sorry about that. I got mixed up. Oh, okay. Just move them slightly down, just for some editing purposes. So what I'll do now is I'll insert like a hanger for the hollow cores. So what will happen is I'll select a hollow core that I want to support. I want this one to be supported. Click finish, and I want to select the hollow cores that will be supporting. And what will happen is I want to say get a cutout from this hollow core. Yes. To somewhere here. Like that, and I'll select this hanger. I've got a hanger defined, so this will allow me to edit this hollow core so it's hanging and supported on this particular edge, and of course it will be visible in the 3D view for us, like so. So we've got a hanger. How do you do openings? Let's go level 2. Very simple. You go. We can go ahead and. Not here. Insert. Recess. Draw recess. here, and I can user define a I can specify a recess, for example, size. I could pick face and pick recess lines, but for that I need to go back and actually create a model line. Pick a plane, level 2. Okay, and create a rectangle, say like so, should be good, like that. I can move that slightly, just okay, now that's fine. And let's go impact, let's draw recess and user define, pick face of the hollow core. Okay, got it. It's going to be a cutout, pick recess lines like this, this, finish. And okay, so this will cut out the update. So that's how we cut out the elements as well, basically. All right. There's also an option to do core fillings. We can do that very quickly and do core fillings. Let's go level 2 and let's go select the hollow core. Let's select the fillings here to here, and let's remove core number 2, 3, 4, 2, 3, and 4. Let's delete those, and let's leave the other ones as well. So you'll see how that works. So we've got some core fillings there, like so. Here we have a channel cutout. That's because of the end cap that's applied, but you see we've got fillings visible here. If you go 3D view, we've got some fillings placed as well. So that's how you do that. Now with that done, let's actually go ahead and apply the reinforcement, get the drawings out. But first we need to save the elements. So let me actually select all my sandwich walls like so without those. On the first floor, we'll make it easier, and let's save those to the database. So save walls. Oh, I forgot. Let's not save them yet because I need to apply the reinforcement to them. Yeah, I see we've got like 10 minutes left, and I wanna show it. I want to show everything, and I always want to show too much, so I don't always fit in that 1 hour mark that we have for the presentations. I'm going to close that window and explain that a little bit later. But let's apply the reinforcement template for our sandwich panels. Let's go sandwich panels like that. Let's select the WA 3000 and select, say, those panels. I'll just select those just so we don't waste time while it applies. It's pretty quick, but it will still take a little bit of time. And I'll show you how you will be able to see all the casting materials and all the reinforcement in another view in just a second. So it's fairly quick to add that reinforcement. I'll show you where you define that in a second once this is applied. But basically I applied the reinforcement template. I selected that from a list, and I'll show you where the definitions are so you can play around with that on your own if you go ahead and get Impact Revit trial. And that's done. You can see the reinforcement here, but you can go ahead and go to Impact All Reinforcement view, and you'll be able to see the reinforcement, the elements. You get the rebar, you get the additional window reinforcement, etc., right? You get the cutout reinforcement out. Everything is automatically applied, so you don't have to worry about it. Where do you find it? Under RC templates, you apply some reinforcement for wall panels. You can define that here. So the layout, is it double mesh or double rebar? Is it a single mesh, single rebar? What are the covers? What are the offsets? Do you want some edge reinforcement around the panels? Do you want corner reinforcement around the panels? So basically you can specify some shapes as well, shape codes for the reinforcement. Do you want opening reinforcement? Do you want end cap reinforcement? If the end caps have assigned reinforcement in them, you can assign some spacing to this reinforcement as well. Or you can create some additional reinforcement extra between the bars if you need to do that. Or what types of meshes do you use? And in this particular case, I'm using those N5200 meshes and N6150 mesh as well for the outer panel. And I'm going to close that, not to change that. So that's how you do that. I'm going to add reinforcement to the columns and beams as well. And those you add with rebar templates. Rebar templates though, let's go columns. Rebar templates, you actually create those with the Revit rebar engine and save that template rebar configuration into Impact. And basically you get different shapes, the planes of those shapes, shape codes, the exact locations, dimensions, etc. of all the rebar. So I'm going to apply this rebar template to my columns and my corbels as well. So columns, column templates like that. Click, 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 and click, and finish. And it's assigned immediately, as you can see. It's apply that for corbels as well. Select the corbel reinforcement, select corbel, corbel, and quickly corbel and corbel. And let's finish that. And we've got our corbel reinforcement as well, as you can see. And let's add the last rebar templates really. For that, let's go beam reinforcement for our inverted T beam, like so. Then you can of course edit that reinforcement. You can edit some parameters, you can edit the spacings. So that's a lot of setup that you can do that will automate your work later on. Let's go to the level 1 and let me go ahead and actually start saving the walls. Select. Let's go exit because okay. Let's select that, select that, select that, that, and like that. And let me go ahead and save the walls. Now Impact will open up the little table that you saw 2 times already. It will show you the numbering of the elements that Impact tries to automatically place. You can change that, of course. We'll do that in a second. During the saving of the elements, you can create OBJ files. So with that, you could create OBJ files. I won't be creating those as they take quite a little bit of time. What do OBJ files contain? The geometry of the elements, the reinforcement of the elements, all the casting material, basically everything that you would need for cooperation with different industries, collision detection, etc. So you can also preview that reinforcement in Project Manager, but with Revit, it's kind of not really necessary as you got the reinforcement all in here and you can check the collisions within Revit. And the engine is pretty fast as well, so it's very good. But you could select the how to export the files to OBJ, and you can select if you want to export the casting materials or reinforcement to OBJ as well. But let's renumber all the elements. Renumber, and I want them SW100. And let's do that. Okay, some elements have been unsuccessfully renumbered. Let's say cancel, like that. Okay, there's 2 elements that I want to renumber. Specify new mark, SW 122, something like that. Let's select. Okay, they've been renamed, and let's actually save those elements to the database. There's 24 walls. Once they are saved, it takes not a long while, but once they are saved, you can update the model, and you can already see some elements popping up in here. If they're identical, well, those are not identical. That's because of the directions of the of the elements, but I'm updating the model as we speak, and you can see that the elements are being saved to the database to project manager. So we're getting now our 3D preview. I'm updating that view again, and I'm getting more walls. So Revit is working in the background, saving the elements, and maybe I shouldn't have saved all of those, but yeah, it's working, and yeah, well, soon we'll have all the walls saved and visible in here. So your database is now being filled with data from Revit. There you go. You're getting, of course, the notification here, elements saved successfully. So if you have more elements there, you see which elements are saved and have not been saved yet. That's it. That's saved. If we go update the model, we'll see all the elements now. Oh, I think I selected the sandwich walls here, unfortunately. With that, doesn't matter. Doesn't matter. Doesn't matter for demo purposes. Let's save the columns as well. At least those here, those 2 columns here, and because this will be quick. I'm not going to renumber them. I'm just going to accept the naming convention here, save that, and I'm going to save the beam as well. And after everything is saved and it's in the database, now we can create drawings out of that. Let's close that. Let's save the beam. Let's save this one and exit. And we'll also save the hollow course as well in the database. So we've got a couple minutes left. It's perfect to show you how to get the drawings out. Let's go 2. Let's select all those. Impact, core filling, save whole course. And we'll create just a couple of drawings for each of those elements. Rather, just like one drawing set for one wall, one drawing set for a column, a drawing set for a beam, and a drawing set for a hollow core. Just to make it, just so we don't go over the time too much, okay? Because I don't want to take more of your time than I need to. How do you create drawings? Simple. There's a create shop drawings option in Revit impact tool, and I want to create a sandwich wall drawing. I want to select a sandwich wall. I want to click finish, and it will now impact in Revit will work in the background, and it will try to create the drawings for me for this particular wall. If I had selected multiple walls, I could select if I wanted to create drawings for all of them, but I just selected one, so it's automatically generating the drawings in the background for me. So you can see that it's pretty quick and convenient. Of course, if you create drawings for a massive project at one time, yeah, you're better off just going and grabbing a coffee before that's done. But it takes out the work that you would have to do manually generating that. And why? That's because we set up the drawings to be very accommodating. So you can change the drawing template, or rather the template for the particular drawing element type drawing. So it contains different data, or it's laid out differently. And okay, it will pop up with a window. It will ask me if I want to open those drawings, and I will, just to show you show you everything. And of course, it's worth noting that creating the first drawing and applying the first reinforcement template is always the slowest, although the drawings will be drawn pretty way faster. So let's open those. Let's open those drawings. SW123, and those are 4 drawings that we get. We get the main view, basically the formwork view. You get the automatic dimensions. You get sections as well. If you need more, of course, you can create more sections within those views. This one in particular would probably change the range of that section. I would edit that section here. But yeah. another drawing. It's an inner panel. It should show reinforcement on some of those panels, and it shows reinforcement on the outer panel. Probably some settings for in here. I would have to do structural. Oh, it doesn't show reinforcement here. But you get some reinforcement information as well on the drawing. You've got your 3D view drawing as well. You get the preview of the end caps within here. So all the stuff that you would require on the drawings, you can of course modify and change and make it suit your needs. Let's now go ahead and quickly create a drawing for a column, not a double wall, a column. And let's select a column and finish. So it will create a drawing for a column for us. It will be automatically as well dimensioned. It will give you like the reinforcement schedule, the casting material schedule. Of course, the template is adjustable. You can already see that creating that drawing is way faster than last time. Let's open all the sheets that we create. We get the formwork, so main drawing. That's I clicked the. Oh, did I click a beam? Oh, unfortunately, I clicked a beam on the. Let's actually select that. Unpack, create shop drawing. That's because I used a wrong template on the wrong type of element, so I get a wonky result. But now it should be way faster, and it is. So apologies for that. Happens. I misclicked, didn't notice that I clicked on the wrong type of element. Like that. Let's open that. So we get a 3D view, some with reinforcement, and we get the dimensioning as well. We get sections if there were more. We got the casting material schedule, and the reinforcement. You of course get the reinforcement schedule as well. So that's about it in terms of like drawing creation. You see it's very easy. It's very much automated. All the data in the tables is customizable according to your needs, and the elements are saved in the database. If we update that, then of course we'll get the columns, we get the hollow cores. Of course I created a hole incorrectly here, but that's my bad. So we get a weird little cutout here. You don't get a warning here if you do something silly like that. Here the geometry. Oh, I think I moved the wall to one side, unfortunately. So yeah, the column here for some reason says shown weirdly, but that's like demo purpose of me clicking like crazy sometimes. You got the geometry and you see the geometries. You can control everything from Project Manager. Now if you would want to plan the production of that, you've got your model in, and you can continue on with Impact Production, which I showcased last month. Or a couple months ago actually. Yeah, last year I showed Impact Production last year. I think we'll be also showing that again this year in another presentation, so be sure to follow that, and you'll be able to get notified. So with that, of course, I think we've covered all the topics. I would like to very much thank you for following me in this presentation. We've got everything covered, and with that, again, thank you for your attention, and I do encourage you to visit our website strusoft.com, visit our official LinkedIn profile Strusoft, and our official YouTube channel. And I also encourage you very much to go ahead and on the website apply for our free trial of Impact. Doesn't matter if you want to try it out for Impact, for Revit, for AutoCAD or BricsCAD, or if you want to try out the production, go ahead. No worries. We'll be very happy to help you with you trying out our software. As you can see, it's not terribly difficult to use. There's a lot of icons, but they're fairly straightforward. Learning curve is not too steep as well. A lot of customization that I think will be very accommodating to any type of your workflow that you have. So again, Thank you for your attention. Go ahead, apply for a trial, and have some fun with Impact. And I would like to, hopefully see you again in another presentation. Goodbye.